So hi everyone, welcome to my YouTube channel. So in this video I am going to explain you about the experiment on thermal conductivity by Lee's method. So aim of this experiment is to find out the thermal conductivity of a given material by Lee's method. So for this experiment the apparatus required are two thermometers, and this is the Lee's apparatus, or we call this as the Lee's disc, and this is the steam chamber, and this is the bad conductor, that is cardboard we are using, and as I said, this is the Lee's disc, and to attach this Lee's disc we require the string, and this is the stand, and we can measure the thickness of this cardboard or the bad conductor with the help of screw gauge, and vernier caliper is helpful to calculate the diameter of this disc. And here is the heating chamber. Actually along with this experimental kit they have to provide a heating chamber, but here I am just explaining you how actually this experiment we have to perform. So to heat the water we require heating chamber, heater we require. So I am in that case alternate option is I am just replacing here this heater. So this is all about the apparatus we require for to perform this experiment. So first what we have to do, we have to keep this disc, that is the cardboard, on the Lee's disc, and we have to keep this steam chamber above this cardboard. So this bad conductor must be between the steam chamber and the Lee's disc or the metal disc. So next, here we require the tubes to connect the steam chamber to the heater. So here they have not provided tubes, so you can understand how we have to connect the tubes to the heating chamber. Here they have given two. One is inlet and another one we can take it as outlet. So you can connect here the inlet to the heating chamber or the heater, and then once the heater start heating the water, steam is going to generate. That steam must pass through this chamber, and this is the outlet. You can connect the tube. So whatever the steam has been generated, it must be come from outlet. And here we can see the holes here for this Lee's disc and also this heating chamber or the steam chamber we call. We have to insert the two thermometers inside these two holes to measure the temperature across the steam chamber and this Lee's disc. So you can see here I have inserted the thermometer inside the holes. So first this is for steam chamber and this is for metal disc or the Lee's disc. So once you start the experiment, when the heater has started the boiling water and steam is going to generate, you can insert this thermometer to measure the temperature across the steam chamber and this Lee's disc. So initially they are at room temperature. When steam is going to pass through them, its temperature, their temperature is going to rise. You should note down the temperature across them. So once they reach the steady temperature, then you can remove this cylindrical vessel or this steam chamber. So you should note down the temperature of the chamber, that is steady temperature. Once you note down, once you remove the cylindrical vessel, so here only we have to remove the steam chamber or the cylindrical vessel, and we have to keep this cardboard or the bad conductor as it is on the least disk. And here the least disk also has reached the steady temperature. We have to wait up to the 10 degree Celsius rise above the steady temperature. So we have to make the observations for cooling of this least disk or the metal disk. So we have to use the stopwatch. For every 5 minutes the decrease in the temperature across this least disk we have to note down. So here is the tabular column. So for each 5 minute increase, the corresponding temperature we have to note down across this least disk or metal disk. So you can take up to 10 to 15 readings. Then you have to plot the graph here. So here is the nature of graph, that is temperature versus time. So once you plot the graph of temperature versus time, you can calculate the slope, that is given by rate of change of temperature d theta by dt. So the slope, if you calculate, you can calculate the thermal conductivity. There is a formula for that. So here is the formula to calculate thermal conductivity of a given material. K is equal to m into s, d theta by dt, d by a. In the numerator you are going to have the theta 1 minus theta 2. So first you should know these terms. M is the mass of this disk, and they have given here mass of the metallic disk is 933 gram, and specific heat of the metal is 0.09. Diameter of the disk you have to calculate here. So the diameter of this disk nothing but this cardboard. You have to use this vernier caliper to measure the diameter. So you can measure the diameter of this cardboard or the disc with the help of vernier caliper. So here it is about 11.809 centimeter we have to write here. Radius of the disc, once you calculate the diameter, take d by 2, you will get the radius. Thickness of the disc you can calculate using the screw gauge. So thickness you have to calculate. So thickness is about 0.9 centimeter you can say. Then temperature of the chamber, that is when it reaches the steady state, we have to note down the temperature. And temperature of the disc when it reaches the steady state, T1 and T2 are the steady temperature of the disc and the chamber. So once you have all these values in this equation, you have to put and calculate the thermal conductivity. So here is the calculation for diameter from vernier caliper and thickness from screw gauge. So radius you can find out. So put all the values here. M, S, specific heat, d theta by dt, that is slope from the graph of temperature versus time. D by A is the area, pi r square. You have to put here pi r is what, radius, 5.90, pi 3.142, and area you can calculate and put that value. Theta 1 minus theta 2, steady temperature of this chamber and the disc. So then you can calculate easily the thermal conductivity. Once you calculate, you can write the result, that is 2.5 into 10 to the power minus 3 Kelvin per second per centimeter per degree Celsius unit for that. So for the given material, they got the thermal conductivity of about 2.5 into 10 to the power minus 3. and the unit you can observe.